Okay, today we're going to look at Lesson 6, which is Section 1.5 in your textbook. And our I can statement or learning objective is I can solve compound inequalities. So remember, you should have your composition notebook with you. You should be taking notes as we go. Feel free to stop or rewind the video whenever you need to get caught up. So the first thing we're going to do today is the vocab. We only have one term. It's compound inequality. Now, if we were in person, I would ask you about compound words. And I would ask you to tell me some compound words. So, and since we can't do that, I'm just going to ask you, or I'm just going to tell you. I'm not going to ask. I'm going to tell you some compound words. Cupcake, football, basketball, hot dog. All of those are compound words because you take two separate words that mean different things and put them together to create a new thing. Like butterfly. Butter plus fly makes butterfly. Okay, and that's a completely new object, a new thing. Compound inequalities are very similar in that aspect. We're going to take two distinct inequalities, and they are joined by the words and or. So we're going to look at inequalities. We're going to have two separate inequalities joined together, and we're going to use and or to do that. Now, you guys are honors, so we have to look at something that we wouldn't normally look at in the regular classes at this point. We need to talk about interval notation. We're going to learn how to use interval notation to show our solution sets for inequalities. Okay, and then we'll use these again in a couple sections. Okay, so for interval notation, I'm having trouble speaking today. I apologize. For interval notation, we have some different symbols that you need to see, be familiar with, and know what they're called. So we'll do that real quick. Okay, so for interval notation, we have infinity. So this is a positive infinity. It goes to the positive numbers on and on and on forever. We have negative infinity, which is the opposite of positive infinity. That goes to the negative numbers farther than you can imagine. We have parentheses. We're going to use parentheses when we have greater than or less than. And we have an open circle on our graphs. Okay, we have brackets. We use those for greater than or equal to, less than or equal to, and when we have a closed circle. So the parentheses and brackets kind of act like our open and closed circles for interval notation. We also have this uppercase U. That means union, and we use that for or inequalities. We also have this upside down U. We call that an intersection. It's like an N for intersection, and we use that for and. I made a little star there. We're not going to use the intersections right now. You'll probably see them later, but for now, you just need to know that the opposite of union is intersection, and we use that for and. Okay, but you don't have to focus on that one right now. So take just a second, pause the video, make sure you have all of the notes taken down to this point because we're going to work on some examples. And when we do the examples, we're going to solve the inequalities. We're going to write our solutions. Okay, we're going to graph them, and we're going to put them in interval notation. Okay, so take just a second, make sure you're ready to go. Okay, for our examples, we're going to do some or inequalities first. So number one, we have k plus 3 is less than 0, or negative 5 plus k is greater than 4. So let's solve those really quick. So we subtract 3 and get k is less than negative 3. Or, okay, we add 5 and we get k is greater than 9. So our solution is either going to be less than -3 or greater than 9. Now, we'll put that on a number line. I'm just going to sketch out a really basic number line. In your Math Excel, it'll have the line for you, nice and pretty. But for now, we'll just sketch it out the best we can. Okay, so K is less than -3. So we need to find -3 on the number line. It's less than, so that means it's an open circle. And we want the numbers less than -3. So the numbers that are less are going to be to the left. All right, now the other one is K is greater than 9. So we find 9 on the number line. It's greater than, so it's an open circle. And we're going to go to the right because that's the side where numbers are greater. Now, that should not be anything new to you. You should have solved compound inequalities before. You know how to graph inequalities. We just did that. Now comes the interval notation, okay? So, looking at our first inequality here, so, and looking at the graph, so the arrow is going to -infinity. So, we know that solution set, it's going to be from -infinity to -3, okay? That represents that arrow going on and on forever and us stopping at that -3. Now, we need to decide if we're going to use brackets or parentheses. All right, so parentheses are when we have an open circle. Brackets are when we have a closed circle. The brackets mean that number is included, okay? Parentheses means it's not included. So if we think about infinity, do we know where infinity stops? No, because it doesn't. So anytime you have an infinity symbol, you're going to do parentheses, okay? So infinity symbols always have parentheses. Now, -3 is an open circle, so we're going to have parentheses there as well, right? Or if you go back up to our list, we use this U for or, so I'm going to put the big U there to represent union. Now I'm going to do K is greater than 9. So we're starting at 9, and it's going to go on and on and on forever until positive infinity. So I'm going to do that positive infinity symbol. We have an open circle on 9, which means 9 is not included. So we put parentheses. And infinity, we don't know where it stops, so we have to put parentheses there as well. Okay, so this is your solution set in interval notation. So the math problems there that you had to solve, those little inequalities, those are pretty simple to solve, but then your solutions have a few different steps. So you solve the inequalities and get your solutions, you graph them, and then you put them in interval notation, okay? So that's the same kind of process that we're going to follow. Okay, here is example number 2. I would love for you to pause the video, write example number 2 down, and give it a try, and then we'll check our answers together and just see how you did. But don't stress if you're unsure of how to do it. Just give it your best effort, and you can always fix it. Okay, hopefully you've had a chance to give it a try and just see what you can do. So you probably can at least solve those one-step inequalities. Okay, so number 2, we divide both sides by -3, and we get x. We divided both sides by a negative, so we have to flip that symbol. 6 divided by -3 is -2. Or, on the other one, we have 4x is greater than or equal to 20, so we divide both sides by 4 and get x is greater than or equal to 5. All right, so we've got our 2 inequalities. Let's put those numbers on the number line. So we have -2 and 5. Let's graph those. On -2, we have less than, so we have an open circle, and the numbers that are smaller are to the left. And on 5, we have a greater than or equal to, so that is a closed circle, so fill that in. And we want numbers that are greater, so we're going to the right. Okay, now for the interval notation. So we're going to follow the same process we did over here. We're going from, we have all the way to -infinity. So I'm going to say negative infinity. I'm stopping at the number -2. All right, what symbol did we put on infinity? Parentheses. On the 2, it's open, so we close the set of parentheses. Or is union, so we're going to put a big U. And now let's do the other one. So we're starting at 5. This time your circle is filled in. It's closed, so we're going to use a bracket. And we're going all the way to positive infinity, so put a positive infinity symbol. And again, infinity has a set of parentheses, or half of a set of parentheses. All right, so there is your solution. Again, there are 3 parts to our solutions here. We have the inequalities, we have the graph, and we have that interval notation. Okay, here are examples 3 and 4. Write those down, give them a try, see what you can do, and then we'll check our answers together. Okay, number 3, we have 8n plus 3 is greater than 67, so let's solve that. You'll end up with 8n is greater than 64, so n is greater than 8. Or, over here, solve that one, so you'll subtract 7 and get 3n is less than or equal to 9, so n is less than or equal to 3. All right, so let's put these numbers on a number line, or these inequalities on a number line. All right, so this one's a little bit different because we have an 8 over here and a 3 here. On the number line, they're going to be in order. So the 3 should be here and the 8 should be there. All right, n is greater than 8. That's an open circle to the right. N is less than or equal to 3. That's a closed circle and to the left. Now let's make our interval notation. So we have negative infinity, and that looks like an 8. So let me fix that. I apologize. So negative infinity, and we're stopping at a 3 this time. Infinity has parentheses. The 3 is closed, so we use a bracket. It's or, so we have that U for union. And on the other side, we're starting with an 8 and going to positive infinity. The 8 is open, so we use parentheses. Infinity is open, so we use parentheses again. So there is your solution. The inequalities, the graph, the union. Now, here's something that I want you to notice. All of our OR problems, the graphs look very similar, okay? All of those lines or the shading, arrows, whatever you want to call it, they're all going to the outside of the number line, okay? And all of your interval notations look very, very similar. You've got infinity and parentheses on the end. You've got the U in the middle. You just have to really pay attention to the numbers that you're stopping at on each end, and if they need brackets or parentheses. Okay, one more. Let's do number 4. So if you solve this 2-step inequality, you should get x is less than or equal to -4. Or the other one, you should get x is greater than 6. And if we put those on a number line, -4 is down here and 6 is somewhere up there. -4 is a closed circle and to the left. 6 is an open circle and to the right. And now let's make our interval notation. So look at your graph. We have from negative infinity to -4. Okay, infinity is not included because we don't know where it stops. -4 is included, so we use the bracket. U for union. On the other side, we have a 6. It's open, so parentheses. And then positive infinity is also open, so we use parentheses. Okay? So you have some problems like this in your Math Excel. You have some OR problems. Some of them will ask you for interval notation. Some of them will not. So just pay attention to what it's asking. Okay? Okay, we're going to switch gears now and look at some and inequalities. So for and inequalities, they're joined by the word and, or sometimes you'll see the problems a little bit differently. They'll be squished together, okay? So we're going to look at them separate first, and then we'll look at them together. All right, so 2x is greater than 2. So if we solve that, we're going to have x is greater than 2. If we solve the other one, we're going to have x is okay, we're going to switch gears a little bit and look at some and compound inequalities. You can see and compound inequalities two different ways. You can see them squished together here as one long inequality. You notice there are two inequality symbols and one expression in the middle. Or you can have them separated with the word and. We're going to look at both ways because you're going to see them both ways, okay? So if you have one that's squished together, you can look at it like this. That's one inequality. You can look at it like this. This is another inequality. But since they're squished together, we can solve them both at the same time. So look at the expression in the middle, x plus 6. How do we get x by itself? We subtract. So we'll minus 6. And if we do it to one side, we have to do it to the other. And in this case, there are 3 sides. So we have to subtract 6 on all 3 sides. All right, let's simplify. Negative 4 minus 6 is negative 10. It's less than, x is in the middle, less than or equal to 5 minus 6 is negative 1. So here's our answer. Here's our solution. Negative 10 is less than x is less than or equal to negative 1. That means that x is actually bigger than negative 10, and it's smaller or equal to negative 1. So x is somewhere between these two numbers. All right, so let's graph that on a number line. All right, I have negative 10 and negative 1. If you look at negative 10, it's got an open circle. Okay, negative 1 has a closed circle. And if x is between those two, that means our shading is between those two. So your arrows will meet in the middle. You can just have one solid line, whatever you want to do there. Okay, so your solution is somewhere between these two numbers. Now, something important to note is that you could break these apart and have two separate inequalities. Okay, I'll do that over here to the side just so you can see. If you take it apart, negative 10 is less than x. That's the same as x is greater than negative 10. This one, x is less than or equal to negative 1. Okay, those two inequalities are the same as this. Okay, this matches your graph a little bit better. It makes it easier to see. Now, we're going to do the interval notation. So this one's a little bit different because your solution is squished together. You don't have two separate things. Like before we had this or that. And is together, okay? So like if I said you can have cookies or ice cream, you have to pick. But if I say cookies and ice cream, you get both together, okay? So when we do interval notation, we're just going from negative 10 to negative 1. So negative 10, let's write it down. All right, it has an open circle. So that's parentheses, comma. We're stopping at negative 1. Negative 1 is a closed circle. It's included. So we close that with a bracket. And then we're finished. Okay. Now, in your Math Excel, some of them are going to ask for interval notation. You're going to have to pick the correct graph. And then some of your answers, if it says and, then I think all of your answers are going to be squished together. You can write them like this out to the side if it helps you. Or if they're separate, you can get an answer like this and turn it into one long compound inequality. Okay, here's example number 2. Pause the video, give it a try, and see what you can do on your own. Okay. In the middle, we have m minus 4. It's another one step. You could have 2 steps in the middle, and you do it the exact same way. You just do the 2 steps to every single piece. So here, we would add 4 to all 3 sides. Negative 3 plus 4 is 1. You have less than or equal to m, less than or equal to 3. So m is between 1 and 3. So on your graph, your solution, your line, your arrows, your shading, whatever, should be between 1 and 3. So let's make that number line. So 1, we have a closed circle. 3, we have a closed circle. And m is somewhere in the middle. So our shading or our line is going to go in the middle. Okay, now let's do that in interval notation. So we have a 1, and it's closed or included, so we use the bracket. Then we have a 3, it's closed or included, so we use another bracket. So our interval is just from 1 to 3, and you can include 1 and 3 in your solution set. Okay, number 3 looks a little bit different. It's still and, but this time your 2 inequalities are separate. They're a little bit different, and you're going to have to solve them and then put them together on your graph, your answer, and your interval notation. So you're going to solve each inequality separately. Okay, so the first one, 3x is greater than or equal to negative 12. That's x is greater than or equal to negative 4. And if you have 8x is less than or equal to 24, that's going to be x is less than or equal to 3. And so what you'll notice is that if you think about if x is bigger than negative 4, so that means it's going to the right of negative 4. It's smaller than 3, so it's going to be going to the left of 3. And when we put that on our number line, let's look and see what happens. Okay, so we have a closed circle on negative 4, and we want what's greater than. So we're going to the right. We want less than or equal to 3, so that's a closed circle, and we're going to the left. And your lines, your shading, whatever you want to call it, meet in the middle. So even though these 2 inequalities are separate, their graphs look just like the ones that are squished together. Okay, now let's use this to put our answers in one long inequality. Just like in number 1, we said we could pull them apart. Down here, if they're apart, we can put them together. So x is going to be, it's bigger than negative 4. So that means negative 4 is less than or equal to x, and it's also less than or equal to 3. Okay, we can use the graph or that to put it in interval notation. So we have negative 4 and 3. Okay, that negative 4 is included, so we use a bracket. 3 is included or closed, so we use a bracket. And there are all the parts of our solution. Okay, now what you notice is this looks very, very similar to a coordinate point. Okay, and some of you might be wondering, well, how am I going to tell the difference between a coordinate point and an interval? Well, the main thing is look at the context of what we're talking about, okay? If we're talking about an interval, a span of some numbers, then it's going to be interval notation, okay? And interval notation just has one variable. We just got an x or an m, okay? That's interval notation. There's only one variable. A coordinate point has 2. It has an x and a y. So when we start talking about coordinate points, you'll know it's a coordinate point because we have an x value and a y value together. Okay, but don't get hung up on that right now. We'll talk more about that when we get there. Okay, here is example number 4. Pause the video, give this one a try, see what you can do on your own, and then come back and check it with me. Okay, let's see what you got. So 2x is greater than 2. That simplifies to x is greater than 1. And 2x is less than 4. If you solve that, you're going to get x is less than 2. So that means x is bigger than 1 and it's less than 2. So it's somewhere in the middle between 1 and 2. So for this one, I'm going to go ahead and put this inequality answer. So if I said x is between 1 and 2, okay, so x is bigger than 1, it's smaller than 2, it's somewhere in the middle. Let's make our number line. There's an open circle on 1, an open circle on 2. Our shading where our solutions are in the middle. Now let's make interval notation. So we're going from 1 to 2, so 1 to 2. We have an open circle on 1, so it's parentheses. We have open circle on 2, so that's another set of parentheses. And there is your final answer. So all of this can be included in your answer or your solution set. There's just different ways to write them. Here's and separate. There's and together. This is how Math Excel is going to want you to enter your solutions. There's the graph, and then there's your interval notation. And the last thing we're going to talk about today is just a little extra problem because you guys are honors, and so you will see problems like this eventually. You won't see any in your homework today, but you can stumble upon these later. So here we have a compound inequality, and we have variables in more than one spot. So your first inclination might be to just work this out or solve this like you would any other two-step inequality. You would add 1 to all 3 sides, and then you could get your x's together. But what you'll find out is since you're doing everything to all 3 sides, you will just be going in circles and nothing will be working out. You're just going to keep moving the stuff around and not really solving it. So if you end up with a compound inequality and you have a variable in more than one spot, okay, in one of the 3 sides, then you're going to have to break them apart and then solve them. So what we would do is we would create 3x is less than or equal to 5x minus 1, and 5x minus 1 is less than or equal to 19. Then you would solve each of these just like we did before. So on the first one, we could subtract 5x and get negative 2x is less than or equal to 1. Then you can divide by negative 2 and get x is greater than or equal to negative 1/2. And on the other side, we can add 1 and get 5x is less than or equal to 20. And that gives us x is less than or equal to 4. Okay, so there is our solution set. Then you can create one inequality because x is bigger than negative 1/2, but it's less than 4. So that's the same as saying x is, hold on just one second. So sorry about that. So that's like the same as saying x is between negative 1/2 and 4, and then you can graph that on a number line just like before. You can put that in interval notation just like before. Okay, so that's just a little extra look at something you might see later. You don't have to worry about it right now, but just a heads up. Let me finish that little number line real quick. All right, there you go. So your Math Excel work, it's going to be a combination of or and problems. You might have to write your answer as an inequality. You might have to write it as interval notation. You're going to have to graph your solutions or choose the correct graph for your solutions. So just make sure you get all these notes and examples written down. Use them to help you with your Math Excel. And as always, if you have any questions or concerns or issues, let me know. Have a great day.